Okay, now on number 3, we're going to be doing some algebra with these functions, f of x and g of x. For part A, we're finding f at negative a. So you're going to go through your f of x function, and in place of that x, you're going to substitute a negative a. Now the negative a, I'll square it, which will give me a positive a squared. So your final answer for that one would be the 5a squared minus 4. On part B, we're finding g at x plus h, or g of x plus h. So everywhere in this g function, you're going to substitute an x plus h instead of the x. So when I do that, it's going to look like this: negative 3 times x plus h squared minus the 2 times x plus h plus 1. And then I want to go ahead and multiply that out so that I can combine any like terms. X plus h, make sure when you multiply out x plus h, we square that binomial, and it would look like a negative 3 times x squared plus 2x h plus h squared. We're going to multiply that negative 2 by distributing to both of those terms, negative 2x minus 2h plus 1. Then distribute the negative 3 to that trinomial, so that would be negative 3x squared minus 6h minus 3h squared minus 2x minus 2h plus 1. And there are no like terms there, so that will be your final answer. Moving on to part C, we're going to take f plus g of x, which is f at x plus g at x, and we're going to add those two functions together, combine like terms, which would give me this 2x squared minus 2x, and the negative 4 plus 1 will give you that negative 3. Same idea with f minus g of x, but be careful when we write this down. We've got your f of x, which is the f5x squared minus 4, minus, and in parentheses you want to put that function so that we'll remember to distribute the negative to all three of those terms. So this will actually become 5x squared minus 4 plus 3x squared plus 2x minus 1. Be careful with your signs. And then combine your x squared terms, 8x squared plus 2x, and then the negative 4 and the negative 1 are going to combine to give you that negative 5.